Well, I don't know if this is working yet. Well, maybe someone can let me know in the chat if you guys can actually see any of this. Well, let me ask. Well, how about now? Let's see. So, can you guys see me now and hear me? Well, it does look like it's working. Oh, perfect. Okay, so let me remove it. Okay, so I guess it's working now. So I'm gonna have to close this because this doesn't seem to be working anymore. And we're going to pop up this one. Let's see if this works. Perfect. Okay, actually worked the first time. That doesn't happen very often. All right, well, first off, I am really sorry, but last week some stuff came up. It was completely unexpected. I was supposed to be here on time and everything was set up just like it is now, but then it didn't work out. And I realized that there was quite a few people who were waiting for a long time, and some of you from places that obviously had to get up quite early or be up pretty late to see it. So I appreciate that you guys came. So this is obviously free form, and we can talk about whatever we want. And let's see, I've never done this before, so I gotta figure out what is the best way to coordinate. Okay, so since everything's working, we can get started. Whatever you guys want to talk about, we can talk about. And I have dedicated some more time, so we should have enough time to do this. The cat is good. I'm sure he'll show up. He's here somewhere. He's always here. So he's gonna come up, I'm pretty sure, and I'm gonna try and capture him and see what he's up to. Advice on RF electronics for a beginner. Well, the thing about RF electronics is that one of the things that makes it so difficult to work with is that there is a particular intuition you have to develop, and that intuition takes time. So when you first jump into RF electronics, without the intuition, nothing makes sense, and it takes a while to build that intuition. It's so different. Some aspects of it are so different than traditional digital or even analog electronics. So obviously it takes time. The best way to start is, well, there's almost an infinite amount of information freely available, which itself is quite amazing. But you have to read some books and understand some of the theory so that you can slowly build the intuition. And that's one of the goals of my channel, right? To bring some of that for free available to everybody so you guys can just learn from it and then develop your own intuition. But it's one of those things that takes time. It's definitely not a fast thing to pick up. Yeah, the amp hour was really fun. I definitely really enjoyed the amp hour myself. It's always nice to talk to Dave. He's an excellent interviewer because we didn't prepare for anything. It's just diving into it, and he figures out the kind of questions to ask and guide the conversation. That's not an easy thing to do. If you ever try to interview somebody, that's pretty difficult. So I really appreciate that. He's a really, really, really nice guy. I went to visit him in Australia, and he basically hosted me, took me around. We went eating and drinking and to the museum and so on, and it's amazing. I mean, to know somebody from across the world only through their videos and then show up and then have a connection and hang out, that's pretty amazing, pretty special. So, wait a second. It's going to keep scrolling. Okay. So I answered that. Yes, the painting is pretty amazing. It's very large. Yeah, my girlfriend painted that. It's in oil and canvas, and it's a replica of what Jean-Luc Picard has in his room, basically on the Enterprise. So it's a really special painting for me. About the math, yes, there's a lot of calculus involved in RF. That's to be expected. Of course, you need to know some of that. But the theory and the really detailed math is useful as an initial place to understand. Once you understand it, then you can kind of move past it. And if you ever need to work really mathematically, you can always go back. But it's not like I'm sitting there solving calculus every day. There's a lot of simulation tools and so on that help. But if you don't understand the fundamental, and that's a big limitation. That's why the math initially is really important. So my PhD topic was on high-speed data converters, particularly for millimeter wave analog to digital converters and digital to analog converters. Millimeter wave simply means that the sampling speed of the data converters were above 30 gigahertz. And at the time when I was doing that, actually those devices did not exist. It wasn't until optical coherent communication really took off as being a major backbone of telecom, where people started starting to research on how to build millimeter wave data converters in CMOS. And the problem was that in CMOS, building really, really fast data converters means that you have to have many data converters in parallel. And they're clocked sequentially, essentially. They're time interleaved. Now, time interleaving many data converters together is already very hard, but the calibration schemes that go into making sure that these samples are coordinated in a way that doesn't introduce spurs and doesn't lower the dynamic range and make the effective number of bits worse, that's really tough to do. So that was a whole bunch of research started happening after I had finished my thesis, basically. So that work was kind of starting when I was working on it. Now you can get 100 gigasample per second data converters for 250 milliwatt, which is incredible. And these are what go into optical coherent communication systems. And what I haven't gotten a hang of this quite because I look at the camera, but I should be looking at a chat. The BKDC resistance meter. I have never used it, but BK Precision makes good instruments. I have a couple of them. I've done a couple of videos about them. I don't have too many instruments. Obviously, they are a little bit less expensive, that helps, but that doesn't mean that they're actually worse. I have their DC load, and I have some of their power supplies. They're pretty good. I haven't had any issues with them, honestly. And yeah, digital signals are essentially analog, and that is true. The reason digital signals are analog because we're talking about digital signals operating at very, very high rates. So once the rate is high enough, then there is no real ones and zeros. And intersymbol interference and the analog behavior of the channels and the drivers and the receivers comes into play. It becomes more and more important. So you're treating them like analog circuits and even like RF circuits in many instances. If you're operating at 100 gigabit per second, you have frequency content above 50 gigahertz. So of course that's an RF circuit itself. So it becomes quite difficult to challenging to design those. But that's the way it is. How do I stop this from scrolling? Let's see. You know what this chat needs that doesn't have? That every time somebody types a comment, it should have an alternating background color, like a gray color or white color, so you can see individual messages. It's such an easy thing to do. Love to see a video building a TDR for testing PCB traces. Yeah, I've thought about that, and there are instruments that do TDR specifically for that. TDR is like a poor man's network analyzer, basically, because you can get phase and amplitude information from a TDR. Is essentially sending a pulse down a channel and looking at the way the pulse changes on the receive side and comparing it and doing analysis on it. And mathematically, you can find for a linear channel, for example, which is, let's say, a passive channel, a TDR is very useful because you can extract the behavior of the channel from the received signal, whether it's an impulse or a step or so on. So they're quite useful, and there are instruments made specifically for that. Nice thing about TDRs is also you can build, let's say, a 36 channel or a 40 channel network analyzer with TDR technology, and that's much easier than doing it using a traditional network analyzer topology. Let's see how I shape slopes, TCD traces. Yeah, so PCB traces that behave differently from microwave signals are nothing more than structures whose size is approaching the wavelength on the PCB. So they are no longer lumped components, they become distributed components. This is a very valuable tool because you can create really interesting behaviors of filters and so on by just putting copper in various shapes on the PCB. So you can imagine why that is valuable, because it is the same process for connecting everything else. So that's why people want to do it. There are limitations of what you can do on a PCB, and that's why you often see fancier dielectric like quartz and ceramics being used on PCBs for when the performance of the filters and whatever it is that they're trying to make, these different kinds of filters, band pass, low pass, high pass, couplers, phase shifters, power splitters, if the performance becomes really important, then they go into dielectric materials that have a much lower loss tangent. And loss tangent is what absorbs energy out of the traces and dissipates them into heat, and that's a function of frequency. So at higher frequency it gets worse and worse, aside from skin effect and other things that happen to PCB traces in general. But it's an inexpensive way to embed components. An antenna, let's say for Wi-Fi, that's just a tiny trace on a little PCB, is basically free, because all you're paying for is a few percent extra PCB area. So of course everybody wants to do that, and this is a very common technique. Is it difficult for hobbyists to get into biosensor design, like organic FETs? Well, so organic FETs are interesting only because they're organic, not because they give you really any capability that normal transistors don't give you. There used to be a time where people were thinking about making transistors out of cells, because cells were so much smaller than what you could build as a transistor at the time. But now a transistor in, let's say, 7 nanometer FinFET process is so much smaller than a cell. So there's no point in terms of packing density. There are advantages of FETs when they're biologically embedded into other organisms, because the interface is, well, organic. So there are advantages to that. I haven't built organic FETs personally, but it is a very interesting field because of the rise in interest in biomedical applications in general, and bringing electronics, machine learning, and devices that embed and communicate with human parts closer together, which is a pretty hot topic. How do I power the equipment in the lab? Well, I have a lot of plugs around the lab, and they're on several circuits, several fuses. So I have enough capacity to, let's say, have one splitter split it in 10 ways, and then there are many plugs. There's enough to power everything. Yeah, it was a bit of a challenge to get that going initially. Any recommendations for RF books for beginners? Yeah, there are. I think what I'll do is that, since I won't remember the exact name now, this is something I've been thinking about doing. I'll try and make a video about just books, a few books that I think are very valuable that helped me. I'll make that. I've thought about it, so I won't forget. BK208040, oh, that's the same question. I honestly haven't used it. We can take a look at it in just a second. RF design, yeah, that's good. Passive for 140 gigahertz and above. Yeah, sure. You can make circuits at any frequency, essentially. The question is, what is the performance you're trying to get out of the circuit? Can you make passives at 140 gigahertz above? Yes. In fact, one of the things we do at Bell Labs is looking at very high frequencies. So we are working on stuff like that, and so are many other people around the world. 140 gigahertz being D-band and above 240 gigahertz. These are interesting frequencies for sensors, for backhaul and for radar, because of the very, very high frequency and broad bandwidth that's available. They give you resolution, spatial resolution. So people like to work at these frequencies. But these are all going to be short range, because to generate power at 140 gigahertz or 240 gigahertz from semiconductor devices, at least silicon semiconductor devices, is really tough. So obviously, that's a subject of research. Yes, X Microwave. So X Microwave is a company where I did a little video about the stuff they had from the IMS industry trade show. If you haven't seen that video, you should watch it. I'm going to do it again this year for a different set of companies. That happens in June. And X Microwave is these kind of Lego building blocks, but for RF. And these things work up to 67 gigahertz. I promised them to get a whole bunch of their stuff and actually do a video. So that's in the pipeline. I haven't forgotten about it. I know the owner and the CEO of the company. We've talked in person several times. So I'm really looking forward to do that. I just haven't had a chance to do it. So yeah, keep that in mind. That's X Microwave is another thing that I'm working on. How can you practice the knowledge of RF electronics without access to ADS, cadence, nor measurement? Well, first of all, there is a lot of free software where you can explore and experiment with some of these technologies. But obviously, it's not going to replace ADS and cadence. But that's true that at some point, you need access to those softwares to do industry relevant work, basically, because that's what everybody in the industry does, and all the toolkits and all the simulation efficiencies and all the fancy things you can do with those tools are written for industry. And these are really, really expensive. And we pay hundreds of thousands of dollars a year for our licenses. So this is very expensive, there is no question. But there are also free ones, which you can learn quite a lot before you get into something like ADS and cadence, which is geared for basically creating products. RF, so this is the other thing, the frequency which you operate doesn't matter. So saying that I've never worked above 1.3 gigahertz, the reason that may seem significant is because at 1.3 gigahertz, the wavelength is still sufficiently long that most of the stuff that you kind of do are still treated like lumped elements, right? But once you get away from the mentality of lumped elements and try to work with things in a distributed fashion, then the upper frequency really is only limited by how much power you have and what is the finest resolution things you can produce once you go to really high frequencies. Of course, test equipment matters, but in reality, the upper frequency that a lot of people seem to have in their mind is the one where you would have to transform your thinking from lumped models to distributed models. So once you learn RF and get away from that, then you can do anything at any frequency. In poor third world countries, how can analog RF electronics benefit the masses? Well, I am from a third world country, or I used to be. I haven't been back in Iran for almost 25 years. It's been a long time, 25 years. But having said that, the technology itself, any technology, RF, analog, optical, biomedical, these are essentially all communication technologies or human interface technologies. So of course, any of those technologies is going to help any country that wants and needs access to the internet. Access to the internet is by far one of the most important, in my view, fundamental human needs, because that's how ideas are exchanged easiest. I mean, that's what we're doing right now. And that's why in fascist regimes, the first thing they do is they shut down the internet, because that cripples people who need to communicate with each other. So I'm all for free access for everyone. Oh boy, I'm not going fast enough, am I? So PCB milling, yes, I have the Bantam Tools PCB machine here. It's a different one than the one I reviewed. I haven't used it really yet, just not enough time. But I plan to do, in fact, what I was talking about before, PCB embedded microwave devices and how to design them from scratch and then mill them on a PCB and then measure them. So that video is also something I like to do. Is the difference in quality PCB material, does it matter? Yes, there are a wide range of PCB materials. They all have different characteristics and properties, different loss tangents, different dielectric constants, and all of those things affect the performance, the shape, the size, and how microwave devices are built. So yes, there's a huge range and a huge range in price. Low noise design video. Yep, I know I keep saying this, but I do have a video in mind for noise, just for noise. Noise is one of those topics that a lot of people don't fully understand. By the way, when I said there's a difference in the quality of PCB, I don't mean in its manufacturing. Of course, there's a difference in how well something is manufactured. So for the same PCB material, different vendors are going to give you different quality. But I was referring to the material itself, that how it affects the performance of microwave circuits. Massive MIMO, hybrid A to D, pre-coding is used to avoid ADC's cost and power consumption. Do you think we will ever be able to reach a point where fully digital pre-coding will be more convenient? Well, we have continuously moved more and more, closer and closer to fully digital computation on every platform, right? So that's obviously moving in that direction. Massive MIMO is a big part of future networks. The 5G, one of the elements of 5G is massive MIMO. And MIMO obviously relies on heavy computation. We've been riding Moore's law for so long that we keep pushing things into the digital. Now things are a little bit changing, but Moore's law is now operating at a different level, at the system level. But indeed, more and more digital. That's the way it is. But that doesn't change the fact that the more you push things to digital, the digital needs to be faster, and the more the digital is like analog. So it's not like these things are going away. This first time watching on a live stream. This is the first time doing live stream. I'm not used to people having civil and serious technical conversation on YouTube chat. Well, no, the audience that I have and many of the other people, we are very lucky. I mean, you guys are not just a random selection of people, of course, professionals. What RF generator would you score off of eBay? So what do you mostly do in your lab? Well, what do I mostly do in my lab here, the lab behind me? Well, I make videos mostly, honestly, because anytime I'm here, I'm either fixing something or creating a new tutorial video and exploring and playing around with stuff. Not that the knowledge that I gain from doing that is not relevant, of course it is, but that's basically most of the things that I do. In terms of eBay, I think this question comes up all the time, and where I get my broken equipment, because I do a lot of repair. And I get it from eBay, but the reason that I have so many and I do so many is because I don't care what I buy. And that's the huge difference. If you're looking for a specific instrument, then yes, it's going to take a lot longer, a lot more searches, a lot more failed attempts at finding and buying and bidding on something. But if you don't care what you buy, you just want to buy something just so that you can make a repair video, then it's a lot easier because your options are open. That's what I do. That's why every repair video is about something else, because I just go look for stuff that's broken that I think would be interesting to open and fix. That's how I do it. But of course, that's not the same for everyone. If you need a multimeter, then you're going to buy a multimeter. You're not going to go buy a synthesizer. But in terms of RF synthesizers, a lot of the older HP Agilent 3 GHz synthesizers have come down in price significantly. In fact, I don't even buy them anymore because I've repaired a couple. They're not interesting anymore. But I do buy the higher frequency ones. So a 3 GHz Agilent synthesizer with baseband generators in there can be had for less than $1,000 or less than $700 even. I've seen them working for less than $700, so it's possible. So rain and snow affecting 5G. Well, one thing to keep in mind is that 5G is not just for millimeter wave. 5G is an entire network architecture. There's low band below 5 GHz, massive MIMO, and high frequency above 28 GHz. So the high frequency 28 GHz and above are definitely going to be affected by rain and snow. That's normal. So is every backhaul link that's right now operating around you. There are lots of millimeter wave signals, point-to-point radios. The challenge of millimeter wave delivery to human beings is how do you work the antennas and how do you get line of sight and so on. So before you get to rain and snow, for millimeter wave delivery to humans who are moving around, there are so many other problems before that becomes an issue. In what kind of company do you work? I work at Bell Laboratories. It's a place where the transistor was invented. It's part of Nokia. And I have a team of very talented millimeter wave ASIC researchers who do ASIC research. I do ASIC research myself. And we built next generation telecommunication integrated circuits for optics and for wireless. And you can see our publications and so on. So we're a small research team, but we've done a lot of cool stuff. I'm very, very happy with what I work. Is analog RF engineering research dead, or is it more likely to be stagnated in the future? Well, as long as you need physical world interfaces, you're going to need analog and RF engineers. There's no question. And the way things always work is that there are cycles. There are cycles of hardware innovation and then cycles of software innovation. Whenever there is a wide availability of hardware, then software takes over, creates a ton of new applications until that is all used up basically, and then new hardware innovations come up and then the cycle continues. So we innovated for a long time, basically creating seamless connectivity. Once the technology for seamless connectivity came into play, then the software guys came over and just revolutionized everything. So now what we're doing is we're taking it to the next level. We're looking at more and more devices that are operating at higher frequencies, the biomedical interface, human to machine interface, very high data rate devices, 5G and 6G research. So there's always something. There's no doubt that right now software is extremely, extremely active with all the algorithms and so on that are used to machine learning and neural networks that go into a lot of the things that we're using right now. So this is, as always, I don't think any of these fields are going away. What drove you to share your knowledge and experience on the internet in the form of the signal path? Well, what happened was in 8 years ago or so. So I teach as an adjunct professor at Columbia University in New York City. And when I originally started doing that, there was some federal law that changed that would not allow me to work in two places at the same time in the United States unless I had a green card. So at the time I didn't have a green card, but I really wanted to teach. I taught 1 year and then the rule changed. So then I said, well, I want to put my effort that I was doing for education into something else, and that's why I started the website. And then after that, it just stuck. I think I may have said this before. Education should be free. I mean, sharing of knowledge should be free, and that's because it's the most powerful tool we have as human beings. If you don't share that, then what's the point? That's in a way how you live forever, is by influencing how other people think and view the world. And I want to share that and give back to the community because I consider myself extraordinarily privileged to be where I am. It's like having won the lottery, living in a third world country, being welcomed to Canada, becoming a Canadian citizen, and coming to the US and being welcomed to the US and working research. I mean, that is the lottery of life for me. So if I don't give back, that'd be pretty selfish, I think. So that's the reason. As a career direction, doomed to stay forever in the field. So nobody is doomed to stay in any field. But having said that, where you work matters a lot. So obviously at Bell Labs, for instance, the nature of change and engaging in different fields is inherent to Bell Labs. That's not going to be the case for every field. Obviously, if you're stuck somewhere where you're doing the same thing day in and day out and you don't enjoy it, there are only a few options you have. You can talk with your managers and say that I want to explore and learn and expand my field of influence and knowledge. And if they are the right people, they will appreciate that. And if they can't, then you would have to go somewhere else. That's just the way it is, unfortunately. And if someday the situation changes and I have to go somewhere else, then that's the way it is. But no one's doomed to stay in anything. But the more specialized you want to become in a field, the sharper the learning curve is. So let's say you're doing EE and then all of a sudden you want to go and do biology. Well, there's a lot to learn. If it is possible for you to do that, then you'll be successful. But it takes a huge amount of effort. There's no question. And I try and change the things that I learn about all the time also. I'm interested in things beyond electronics and things beyond there's Pooj. There he is. So I try to expand as much as possible. But this depends on where you work, unfortunately, to some extent. So my brother lives, do you plan some episodes with your brother, prepare tutorials? Yes, my brother lives in Toronto, so he doesn't live here with me in the US, unfortunately. But yes, we did one video together. We had so much fun. Definitely want to do more. He has a PhD in electrical engineering also. He's an expert in his field, so it will be very, very fun. I want to shield my transimpedance converter, which senses a nanoamp from 50 Hertz hum and noises by putting in a metal shield. Should I connect the device to the ground? Better approach. Ooh, that's a tricky question. If you want to build something that senses something at 50 Hertz, I would build basically a lock-in amplifier. That's the best way to avoid this type of problem. I've done videos on lock-in amplifiers. In fact, I just did one very recently. But yes, grounding the box and all these matters, but it depends on the scenario. It's hard to say. I mean, a ground may not even be a ground the way you think about it. Ground doesn't mean absolute silence. Depends on what is connected to it. There's a lot of things involved. But a chopping amplifier at 50 Hertz would probably be as how I would do it if there's too much noise. Have you done anything with controlled reception pattern? Oh, well, I just lost everything. Oh God, I think I'm going far too slowly. I am never going to get through this. Okay, I lost everything. How do you source such high-end equipment? Do you buy second-hand broken equipment from eBay and fix it to buy? Yes. So that's exactly what happens. So when people jump in some of my videos and they've never seen anything before and all of a sudden they see a super expensive instrument, the reason is because this is not something that happened overnight. It's taken a long time. But a huge part of it are my Patreon supporters. Now, a couple of things I want to clarify about the Patreon support. I don't charge every video to Patreon. My Patreon architecture, first of all, is not month-based, it's episode-based. So unless I post an episode and charge it to Patreon, my Patreon supporters will not be charged. Now, having said that, that means that I basically only put some of the videos on Patreon, the ones that I feel like have enough substance to be worth my Patreon supporters' time, basically, or the money. That's why I don't post everything. I don't want to charge them too much. But the money that you guys have on Patreon that I can recover, it goes all back in the lab. In fact, I spend much more money in the lab than I get from Patreon. So this doesn't make money. It essentially loses tons of money. But at the same time, this is, again, giving back to the community. And I'm very grateful for the Patreon supporters. You guys make some of these things possible. Can we use our RF4? I'm assuming you mean FR4. PCB for frequency above 15 gigahertz? Yes, you can. The higher you're going frequency is just not going to perform as well. But FR4 is pretty good, even at those frequencies. It's basically glass, right? So it's pretty good. What kind of research going on Bell Labs? Tons of research from many different fields, from machine learning, AI, biomedical, math, software, hardware, optics, wireless, you name it. Can you explain how nonlinear transmission lines can be used with comb generation? Yes, so the Anritsu's compact spectrum analyzer from 9 kHz to 110 GHz is a subject that I want to cover, and this nonlinear transmission line circuits are very interesting for generating these high frequency combs, which you can then use to down convert signals all the way up to 110 GHz with very little circuitry that actually operates at 110 GHz directly, and that's the trick there. So I'll cover that. Don't worry, it's pretty interesting. I haven't gotten one from them, unfortunately. Anritsu is one of the only companies that I don't have a direct relationship with. What scope will you recommend for an advanced electronic engineer under 25K? Oh, 25K is still a lot of money, but I would look for, let me see if I have one around here to show you. Actually, you can see it all the way over there next to that black screen. That's a 4-channel 2 GHz scope. You can get that from under 25K from the internet. It's the Keysight one. I forget the model number, but there's tons of options. For 25K opens up a lot. The reason I say used is because you can get a lot for a 25K scope that's used, but a brand new scope with the kind of performance you're thinking about at 25K would be hard. But a good working 25K scope that's a couple of years old would be a fantastic oscilloscope. Do you see a future where silicon carbide, GaN, and silicon are used simultaneously on the same die? Yeah, but obviously for very niche applications, right? You're not going to put GaN and silicon carbide and so on silicon just for whatever reason. But GaN on silicon has an advantage of giving you this extraordinary huge band gap material, which is gallium nitride, on silicon to combine the power, the performance, the complexity, and the integration of silicon with GaN. So you can create really high power devices that have very complex digital stuff on them. So people are chasing this all the time. There are publications on this all the time. And people are working on it for many different applications. There's also 3.5 on silicon for optics as well. That's another very interesting topic. I think it's going to happen. The problem is these are not limited by laws of physics. They're limited by laws of economy. If there is money, people will do it. How did you get into electronics? I've been playing with electronics since I was 6. My uncle was a huge influence on getting me interested in science, and I've always loved it. Started taking things apart since I was 6 years old, shocked many times, stuck things into the plug many times until I learned slowly but surely. But yeah, I've been doing it for a long time. Interesting projects you're working on? Yeah, we work on a lot of wireless 5G related stuff, optical stuff. Obviously the details I can't discuss here, but everything is interesting. Software-defined radio in EMC pre-compliance? Ooh, I don't know. Can you make a software-defined radio with sufficient dynamic range for EMC pre-compliance? Maybe it's pre-compliance. I've never done it. It's interesting. Software-defined radio is obviously going to be tough because they're software-defined, meaning that you capture so much bandwidth and then you software select what you want to look at, but you're consuming the dynamic range of the converter for the entire band. So that's always a limitation. I've never done it, but that's interesting. Yes, Bell Labs does have a silicon photonics team, quite an active one actually, and we have products as well in that domain. Have you done anything controlled reception pattern arrays? Yep, phased array is one of things we work on. Our latest publication, it was a 384 element 90 gigahertz phased array, which has a world record for the highest transmit power and complexity. It has a lot of cool calibration and so on built into it. Phased arrays are awesome. If you weren't doing TSP and working at Bell Labs, what would you be doing? I don't know. I did think about joining academia. Perhaps that would be one of those things, but I'm very happy at Bell Labs. Bell Labs gives me the opportunity to do, Bell Labs is kind of like academia, right? Because you're doing research in a similar way. It's really an amazing place. It's one of the few places left in the world where you can do the kind of research you do, and I hope that it survives because it's expensive and it's difficult. I understand that, but how good is STR as a spectrum analyzer? I think STR as a spectrum analyzer for student RF beginners is fantastic, but like I said, it's going to always have dynamic range limitations, and if you don't know the limitations of an STR, it can be pretty misleading because you put something in and you see all these other tones, whereas these are nonlinearities of things mixing together, and you think they're coming from your circuit. So you need to know the limitations of the STR so you can get the best out of it. That's what I always say. That's why I'm such a big fan of understanding the instrument that you're using, because when you understand the equipment that you use, that's how you can get the best out of it. And same with the SDR. Understand the limitation, the linearity limitation, the bandwidth and the speed and so on and on, and then you can get the best out of it. Oh, I didn't even know you could send money over this. Well, thank you. I appreciate that. I didn't even know this was possible. I think I have probably too much time. What interesting technologies do you see in the future in terms of packaging waveguide interconnects? Oh, that's happening all the time. I know that plastic waveguides is something that you're interested in. So plastic waveguides is basically the idea that if you have a plastic tube, because the center is air and the walls of the tube are made of plastic, just the fact that you have a dielectric difference between those two interfaces will confine fields within it. At very high frequencies, it's going to be a little bit better because the wavelength is small. So therefore, you can use it as a conduit, a very cheap conduit to pass very high frequencies through, which would normally require metallized pieces of waveguide. And then you can do communication over it. It can be interesting for cars, for example, where plastic is lightweight and cheap for using communication. It's an interesting technology. It hasn't caught on very much because of its limitation, because you can't put them next to each other. Some of the field exists outside of the waveguide, at least the ones that I'm aware of. So it makes it hard to connect things and pack them, and they need foam around it and so on. But I'm sure people are doing amazing research. I haven't looked at it since the last time I saw it. Have you ever worked on or read anything about non-Foster circuits? I don't know what non-Foster circuits are. Now I'm curious. Now I'm gonna have to check that out. Do you have to have a master's degree to go into RF communication? No, you don't need a master's degree. You just need to know the material. Now, having said that, there's no doubt that a university degree is a type of qualification, right? So there are places that may not accept you if you don't have a master's degree or something. But mostly it's not degree related, but experience related. But yes, I mean, if you have a higher degree, I'm a huge fan of people going as much as they can in education, right? Because the experience is extremely valuable. At least it has been for me. But no, you can learn it without a degree, and it depends on where you work. Has silicon carbide has replaced? Whoa, Pooj. Not that I know. No, people still make gas LNAs. No, I don't work on silicon carbide personally, or gallium arsenide or gallium nitride or indium phosphide directly. I'm a silicon designer by expertise, but no, they still make different ones. Each of those semiconductor technologies has some benefits, some advantages, and some disadvantages. The biggest advantage of silicon, by far, is the fact that A, in digital domain, it has been riding the Moore's law, and 2, it can do huge complex SOCs, which you cannot do with 3.5 material. That's really where it shines. Would you like to make a video designing linear RF amplifiers using load pull techniques? Well, yeah, I mean, load pull techniques is what you would use to design pretty much any power amplifier. A nonlinear RF amplifier, I'm not sure why you would want. I mean, it depends on the application, but I think I understand what you're saying. Maybe if I do some PA design, we can go over load pull techniques. What is your opinion best method to parallelize MOSFETs in linear region? I don't know what you mean. I mean, you can put transistors in parallel in any way you want, and it just basically means a bigger transistor. The issue with putting transistors in parallel at very, very high frequencies is how you connect them together can have a huge impact on the RF performance in, above 100 gigahertz or above 50 gigahertz. So people spend quite a bit of research figuring out how to connect transistors in parallel on integrated circuits to extract the most out of the devices. Because going to a new node, it's so expensive that you don't want to go into a new technology node and then lose 30% performance because you don't know how to do layout of your circuits. So that's one of the reasons why people spend so much time doing layout. I did a short course at the conference where the topic of the course was the art of millimeter wave layout. It was all about how do you do layout for integrated circuits at very high frequencies, and covers these topics. Why do some network analyzers express the return loss as a negative dB and others use a positive number? I mean, it's really honestly a convention. Loss, negative, positive, is the same. It should be the same. I mean, if you have 20 dB of loss, whether you show the gain as minus 20 dB or the loss as 20 dB, it should be the same thing. What about microcontroller design for RF? Microcontroller design for RF, not sure quite what you mean, but some digital circuits are fast enough that just by digital control you can create RF signals. Normally people don't tend to do that, because if you have a digital signal that's just banging up and down and you create, let's say, 1 gigahertz out of it, that's going to have so much harmonics. For wireless application, that's already a no, because you can't emit all these EM waves outside of the region you're allowed to. You have to confine to a mask for ISM bands, for example, or any band. So that's why filters and so on are often needed. What's confusing to me is if S11 is power reflected, then wouldn't less power return be expressed as a positive number? Oh, no, don't confuse S parameters with how much loss something has. S parameters is a network representation of a very specific type. So it's defined with respect to an impedance and so on. So the math of the S11 defines a particular behavior of a linear system. First of all, S parameters are for linear systems. So whether it's ABCD matrix, Y parameters, Z parameters, S parameters, these are matrices, parameters defining the behavior of a network. Don't confuse them with loss. Loss is a very specific property of a network that potentially can be extracted directly from the S parameters. But those are not the same things. So don't confuse them with respect to each other. By the way, I don't know if I speak too fast. If I do, tell me, although I'm way behind in the chat. I tend to speak fast and it gets worse and worse as time passes. I see Mr. Carlson. Yes, I watched all of Mr. Carlson's videos. It's I like his stuff because he likes to use the old equipment to fix things, and these old equipment are obviously fascinating, and he's such a meticulous engineer. And he likes everything so perfect, and it's really awesome to see, because his patience is certainly more than mine. And I love seeing that old stuff and building things and bringing them back to life. I think it's beautiful. Thank you for nice comments. When designing high frequency RF project, does safety override progress? Does safety override progress? If I understand your question correctly, well, if you have enough RF power, you can damage things, obviously. But that's not really something that 99.9% of people ever would come across. The powers of the devices that you used close by, it's tiny. And it's a simple thing. Go on the internet, type free space path loss calculator using Free's equation. And then type in how much signal loss there is between you and an antenna at a certain distance and a certain frequency. And you see it's amazing that stuff works at all. There's so much loss. What would be the limits of CMOS geometry? Top semiconductor are now 5 nanometer. Well, that's one of the things that's been halting and slowing down Moore's law. I mean, we are at pretty... Oh, geez, now I lost everything. we are at the limits here, and everybody always says we're at the limit. But at some point, yes, we're getting into some nodes which are quite difficult. But if you look, that's what I was trying to say earlier. Moore's law does not have to be specifically about transistor dimension. Moore's law talks about computation power. So systems also follow Moore's law at some way. So you don't have to keep scaling transistors to have Moore's law applied at a system level. But yeah, there are some limits. You can see Intel's now behind us a node or two. TSMC is now dominant on the smallest CMOS node. These guys are unstoppable. It is so expensive to build a fab. Billions of dollars with a B are needed. So not everybody can do it. That's why the number of fabs continues to shrink, because you just can't afford it. Where are you going to get $5 or $10 billion to build a 3 nanometer fab? Where am I from? Well, I'm a Canadian citizen, originally from Iran, living in the United States. Where's the Pooj? He's sleeping in his bed. I think you can see him. There he is. Right there. That's where he likes to sit. I put his bed over there. That's where he is. He's going to come by. If I call him, he'll come. Do you see upper practical limit for bandwidth available on the public? Similar commercial CPUs hitting at a limit of 3 to 4 gigahertz. Yes, the reason processors went to multi-core as opposed to higher frequency is because the optimization for getting more speed, more computational power from a CPU shifted toward multi-core, which meant that some types of new research into software development, writing software that can be split, that can split the problem into multiple parallel paths, showed to be a better economical way of increasing computational power than just keep increasing the clock frequency. That's what happened. That's what I was saying, that Moore's law doesn't necessarily have to do with technology node. I came from Canada. I moved to the US because I wanted to work for Bell Labs. Thank you. And Pooj is amazing. He is a fantastic cat. Yes, what you see before me is my home lab. Everything that I do on the signal path is completely separate from my work at Bell Labs. I don't overlap those in any way. My resources and everything that I use is completely different from Nokia. That way I don't have to worry about any contamination between the two. Machine learning ASICs on FPGA fabric? Absolutely. People do that. FPGA fabric is not the most efficient thing for anything, but it is reconfigurable and it's easy to deploy, and it provides a quick path to market. And nowadays, even FPGAs have some specialized SoC hardware with highly optimized subcomponents to make them more appealing for people who want to do high performance. But yeah, FPGA is a fantastic way to get something to market without doing your own ASIC, which is a huge cost associated with it. You're going 30 seconds per minute. I don't know what that means. Does that mean I'm going too slow? There are a couple of 40 gigahertz broken signal generators. I haven't seen them. The problem with 40 gigahertz broken signal generators is that if the output amplifier is broken, I mean, you're basically dead unless you change the component. Do you have any plan to upload some long-term lectures, deep analysis for something like TSP? Well, it's all a matter of time, to be honest. If I have time, sure. Can you cover? Is it a bigger issue of 5G stuff coming? I can look at that. If you set up an optical communication lab for undergrad, what do you think is the minimum they should learn? Well, depends on what kind of optical communication you're talking about. If you're talking about, coherent optical communication, that's pretty difficult. If you just want to show them that you can send data over fiber, that's not that difficult. I would probably go with VCSELs and multimode fiber as a starting point to get some data link going on and showing them that you can, send pulses and multiple amplitudes. To send coherent light with a phase and amplitude embedded in it is really hard because you need so much TSP to fix that afterwards. So maybe I would start with non-coherent. When did Nokia acquire Bell Labs? I think it's been 2 years now. Did Keysight give you a new UXR yet? No. I don't think Keysight is going to give me a UXR. That thing is expensive. I'd love to have one, but it'd be kind of a bit of a waste, I guess. But hey, if they want to send me one, I'd love to play around with it. I have them at work, of course, but I can't use them for the website. 12.4 gigahertz spectrum analyzer and the external mixer for. Yeah, no, you can definitely use an external mixer, connect it to an SDR, and create a super heterodyne conversion architecture. But the problem is that you're limited by the performance of the mixer and then the phase noise of what you're driving it with and how you synchronize them and how do you get rid of the images because you don't know where the images are. So you have to write software for that. It's possible. I mean, that's basically how high-end spectrum analyzers work. That's what they do. So you're building one with pieces yourself. Were you academically good at school? Well, let me see. So first and second year undergrad, I wasn't particularly very good. I was maybe an average of 80%, let's say. But I got better as time passed. Once I really felt like I was fitting in. I started university a year early, and I think that I didn't have the correct maturity at a time. I should have started university when I was 18. I started when I was 17. So I think that it would have been better if I started a year later. You're way over my head, a lot of stuff. Sorry, I'm trying to answer the question as people have. I don't know how else to do that. Have you done fiber optic work? Yes, I've done splicing and stuff, but that's the physical work in the lab of how do you connect fiber and stuff. My expertise is in integrated circuit design. I also obviously do stuff in the lab, but what I was talking about was building ASICs. You have a lot of equipment. Yeah, I mean the reason there's so much equipment around is a few reasons. First of all, I bought them and I fixed them, and I am a bit of a hoarder. So once I get attached to something, I don't want to get rid of it. That's one of the reasons it builds up in the back. The other reason is because it allows me to have equipment from different vendors, and then it's very easy to see the strengths and weaknesses of different vendors versus each other, and I can use what is best for a particular vendor, and that's why there's a lot of the equipment. I'm trying to scale down. Do you upload live streams for later listening? Yes, of course. I think I'm recording it. Yes, I am recording it, so it will go up as well. About the book, I will do a video on that separately. Calibration signal generator. So calibration of equipment, the difficulty in calibration of equipment is that you need other equipment to calibrate it. The calibration procedure is often not very complicated, but the equipment is not always available. I've done calibration on the website before when we fix something that I can't actually recalibrate. I've done it before. Recommend Art of Electronics third edition. Yeah, so keep in mind, the Art of Electronics is fantastic for playing around with electronics. RF, microwave, transistor level design, silicon integrated circuit design, those are a little bit different. Why is the GUI of expensive RF equipment often so bad? Well, they're not always bad. Some RF equipment have good GUIs. It's because there's a lot of effort spent into creating the hardware. Sometimes they don't make good software, but this changed a lot recently. If you look, a lot of the GUIs of the equipment are so much better than it used to be before. Can you also do a video leveling techniques? Yeah, I think I've talked about that before. Oh, Jesus, so many questions. Next live video gets reported as spam abuse. I don't know what that means. A Pooj-sized elephant or an elephant-sized Pooj? Ooh, that's the toughest question so far. Pooj-sized elephant, eh? I don't know. I'll take a Pooj-sized elephant. You got lucky with that DMM a few months back with the squished power wire. Yeah, so the thing is, I don't know what's wrong with the equipment. So sometimes we get lucky and we get an equipment, what I call lucky is an equipment that's really challenging to fix, because that's the whole point of making the video. If I just wanted to fix something, then obviously the best would be if the equipment just works. But yeah, I don't control that. So sometimes the repair is just nothing really special, something simple, and sometimes it's really involved and complex and frustrating, which is good. That's what we want. So since I just buy broken random things, I don't know always how they are. I have actually a ton of stuff sitting on the other side waiting to be repaired, just not enough time. What would be an advantage of using a Yeegh oscillator with the driver and external PLL? Well, Yeegh oscillators offer extraordinary wide tuning range and excellent phase noise, but they're not solid state. They're massive, big, bulky, require electromagnet, and hard to use. That's why they're used in test equipment because they give the best performance where cost is not a limit. But you're not going to find a Yeegh oscillator in your cell phone, right? Because first of all, you don't need it, and it's just not practical. But dielectric resonant oscillators and other types of oscillators are so good, and the PLL designs are so good these days, you don't even have to have a Yeegh in some of these devices to work for test and measurement instrument, only really, really high-end instruments. Yeeghs can also be used for tunable bandpass filters, which are critical for front-end down conversion stages of super heterodyne test equipment, so that the image goes away and the dynamic range increases, and that's why they exist in a lot of spectrum analyzers that I take apart. Oh geez, I lost it again. Uh-oh. Oh god. Oh, there it is. Can you recommend affordable differential 500 MHz probe? Ooh. I think they've come down in price significantly, actually. I haven't looked at them, but I'll take a look. What do you think about channels like Electro Boom, which particularly show channels based on electronic theory can be very popular? I don't know if there's anybody who doesn't love Electro Boom's channel. He has never given me a shout out. I'm joking. He's fantastic. I'm very happy to see someone who has found a formula and a style of communicating materials about electronics that has so many followers. Obviously, not everybody who follows him is following him because he's teaching electronics, but a wide range of people get an exposure to it because he's talking about it. I'm grateful that he's doing what he's doing. Is there a piece of equipment that would really like to go in your hands on, considering your lab seems to have everything? Oh, there's always something amazing to get your hands on. I would love to get my hand on some of the high-end Roden Schwartz parts. Some of their network analyzers are amazing. Obviously, so are Keysights. Do you see WA? I don't know how you say the name W2A. Yes, I know Alan actually. He's fantastic. Yes, I watch his videos. He's been in my lab. We've done an interview together for Tektronix. How long did it take you to learn about absolute working basics? As long as I've lived. There is no end, honestly. There is no end. And you tend to forget things, too. Learning is never a complete task. But the basics, yeah, I learned during my degree. How many pieces of lab equipment do you have? I don't know. Many. 100 maybe more. I have no idea. I actually haven't counted. Could you make a video about fundamentals of Fourier mixers and all the jazz? Okay. Okay. Is my cat ESD? Oh, absolutely not. Not in the least. What software packages do you use to simulate circuits? Cadence, ADS, the normal stuff. How do you get into Bell Labs? Well, for Bell Labs, often you need a PhD because it's a research institute, but that's not 100% required. I did an internship at Bell Labs while I was a PhD student. That's how the connection was made, and then I went forward from that. Usually I appreciate your videos. Thank you. How were your grades? I think I said that. They were good towards the end. Have you considered building a DUI spectrum analyzer? So here's the thing about, I would like to do that, but then that's so much time it takes that it would not allow me to make videos as often. I think probably it's more valuable to do more videos about how other people have built things and occasionally build some simple things myself rather than spend a lot of time to build one thing. Any SDR recommendations? You know, I haven't looked at SDRs recently. I was thinking about it the other day that I should maybe do that. So I am going to look at that. And maybe actually one of the things I was thinking about doing was to do a video about software-defined radios and their limitations and how they compare with regular benchtop spectrum analyzers. So I am thinking about that. What do you think about the Roden Schwartz SMIQ generator? Agilent ESG, EXG ones. The price seems to be a bit more. Some hacker-friendly, some brand reputable. Both Roden Schwartz and Keysight make excellent synthesizers and vector generators. I don't have a Roden Schwartz IQ generator. I wish I had one. That's one of the things I wish I had in the lab to play around with and find out how it compares. But I don't think you can really go wrong, honestly, with either one. Do you think there's a demand for something like an RF millimeter wave podcast? Well, the demand for a millimeter wave RF podcast would be a fraction of a demand of something like the amp hour. It's just so specific. And this is the problem with my channel in a way, right? Because I have 60 something thousand subscribers. I would love to have 100,000 subscribers. I know it means nothing. It's just such a milestone. Because the channel is so esoteric, the topics are so specific. And in order to have 100,000 people who want to watch and listen to me talk about advanced RF microwave and electronic topics, I mean, that's a pretty big stretch. So I could diversify the topics, and I have done to some extent to attract more people so that they can see these things and perhaps become interested in them. I'd love to have 100,000 subscribers. Were there some courses at university that were boring you? I'll tell you what bored me. The course never bored me, but the professor certainly did. The thing that boring comes from a lack of passion in communication. That's what I found. Obviously, there are limits to that. If somebody came to me and talked about, I don't know, some weird talk about some medieval history thing, yeah, it might be cool for 30 minutes, but I don't want to do a 4-year degree on it, right? Because it's not, I don't find it interesting. So whoever does, fantastic. But it's often the case that I have taken courses that I have vivid memory of, which were not in my field right now at all, that I remember so well because the professors were so good and so passionate. I remember the sentences they said, and that's really stayed with me. And I still sometimes occasionally may even be, that material be useful to me. But I've also had professors who taught me electromagnetics, which is a core of one of the things I do, which I hated because they were so bad at it. And that's an unfortunate thing. By the way, when I said that they were bad at teaching. They were not bad themselves, obviously. It's just that a communication skill is required. Yes, I did say that maybe I'll do a load pull test automotive radar. I did a video about automotive radar. I took apart one, talked about how it works. Maybe we'll do some more. I do have an FMCW radar module that I want to make a video about. That would be cool. If Mars One mission leaves tomorrow, would you go? I don't think so. I would have said yes maybe 15 years ago, but not anymore. But I would love to see it happen, for sure. The reason I don't want to go is because I feel like I've done so much to be where I am. And I'm contributing to the research, and I have a set of expertise which I love and enjoy to do. To jump on another adventure seems to leave one that hasn't completely matured yet unattended. That's probably the reason. Have you ever consider buying a do-it-yourself spectrum analyzer? Yes, just so I can make a video about it. I might do that still. What do you think? What is your opinion about the Libre Silicon Alliance as they create a standard cells high-low tech process thing? I don't know about that. I don't know about this. I have to take a look. Sorry, I don't know about that one. Uh-oh. I don't know why. Oh, I think it jumps once there's too much of it. Canadian here, background also RF engineer. Fantastic. You sound great. What microphone do you use? I use some microphone that the amp hour guys sent me. Dave I think sent me, and it's the same one that from the first time I did the amp hour many years ago. I forget what the brand is actually. Is there a benefit in feeding network traffic into a device like a UXR? Yeah, you can feed all kind of traffic into a UXR, and the software can demodulate it for you. It can analyze it for you. It can give you tons and tons and tons of information. Absolutely, and people do that. UXR is the ultimate software-defined radio. Don't listen to that guy. I don't know who you're talking about. Why all instruments have a 10 megahertz reference clock? Well, that's a bit of a historical reason. So nowadays, if you go and buy a high-end instrument like the UXR or the UXA, they have a gigahertz reference or a 600 megahertz reference. The problem with the 10 megahertz reference is that if I have a circuit that runs, let's say, at 100 gigahertz, and I give it a 10 megahertz reference so that I can lock that instrument to a 10 megahertz reference. The multiplication is huge. So that every time you multiply such a large number and you make a PLL out of it, you are multiplying the noise by that amount. So the phase noise by that amount. So people don't want to have such a huge multiplication ratio for many reasons of how PLLs and locking signals together actually work, and the accuracy of the jitter and the phase noise that you can accomplish by locking devices at high frequencies. So yes, most instruments have a 10 megahertz reference because most instruments had a 10 megahertz reference yesterday, and they have to continue with that. But the high-end instruments have 10 and other frequencies, so you can hook them up at much higher reference frequencies to each other, allowing a far better quality locking. Can you tell us the hardest personal project on which you have worked? Oh, not from Bell Labs. Some of the repairs have honestly been absolutely infuriating. There's personal projects all the time. I do a lot of work around the house, and these things can be really annoying. But yeah, some of the repairs can be frustrating if I have absolutely no documentation, because I reverse engineer, and it's just sometimes can get annoying. Luckily, most of the time it's fun. What was the first piece of RF equipment you bought? The first piece of RF equipment I bought was a spectrum analyzer from eBay with a little CRT screen that was broken. And I fixed it and I repaired it. I was so happy. This was before I even had YouTube. And then now it's gone. I wish I had kept it. That kind of left such a big impression on me. Does Bell Labs accept foreigners? Yes, of course it does accept foreigners. I was a foreigner. Is there any lab in Europe that does the same? Yeah, I think IMEC in Belgium has it for sure. There are Bell Labs in Europe, in France, they are in Ireland, they are in Germany, they are in China as well. So yeah, you can work at Bell Labs and be in Europe. Some of my colleagues are in Europe. Why Terrorem resistors are expensive? I don't know about Terrorem resistors, but I suspect because of accuracy quality. I think Mehdi blowing up, yes, Mehdi blowing up on Reddit had obviously a huge impact on attracting attention to his channel, but that only works because he's good, right? Otherwise it wouldn't work. He's very, very funny. What would it take to make a 10 gigahertz CPU? Silicon. So you can make a 10 gigahertz CPU. You can. The problem is how complex that CPU has to be. And does it make sense to build a 10 megahertz CPU? You can build 100 gigahertz circuits that work in the same technology, but they're not going to be as complex. A CPU is remarkably complicated with so many timing requirements of the digital circuits that have to work together. So, there's also heat dissipation and so on. That's why parallelization has taken over. How can I switch VHF frequencies with the PWM without generating harmonics? You put a filter after it. That would be the easy way. You can also code it for spreading out. You can do dithering to spread out the harmonics and stuff, but then you suffer from phase noise. I agree, believe the electron as I realize. Full bridge rectifier, yeah, I don't know why that is so funny, but it is. Do a video on PXI. I do have a PXI. I did do a video about PXI. You want to look up general scaling this by frequencies, do not raise anymore. Yeah. There's a lot of interest in your lab equipment. I know that many of us would enjoy a video tour. I can do a tour, sure. A lot of the equipment have shown up on videos, but I can do a tour around just to see what's going on. Yes, methodological approach is number one. Scientific method is by far the most important. And I think I've said that before. But science is our most committed effort as human beings to understand the real world for what it actually is, beyond the limitations of our senses and our prejudices as human beings, and the fact that the easiest person to fool in the lab is yourself. So that's why the scientific method is so important, and that's why seeking truth is so important, and accepting things only when there is sufficient evidence for it is critical for democracy and for success of any civilization. That's the number one thing. Any shortcomings that you see from science is not inherently because the scientific method is flawed, but because the people who are trying to deploy and execute this scientific method are flawed as human beings. So that's what we need to work on. An ideal scientific method is the most powerful thing I think we have created as human beings. Oh geez. Uh-oh, I lost it again. More seriously, what are your thoughts about ESD? I have an ESD mat, obviously, that I use when I'm opening things and repairing things. Depends on the environment you're at. Some places ESD is just, and also how dry the air is. So if the air is not so dry, it's not so bad. But yes, I have killed things with ESD. You can kill things with ESD, obviously. But a lot of circuits have ESD protection. We built ESD protection into the integrated circuits we make all the time because of that. You know what I should do? Since we're not using that, why don't I just do this? Should have done that from the beginning. I lost everything again. You need to add more Fortnite fidget spinners. Oh, I guess. Well, thanks. I'm gonna try and hold off on that for now. Can you do an extended video on the analysis of control loops? Have I done a control loop video? Oh yes, I have done some control loop video. Indeed, there are lots of control loops. I mean, PLL is a control loop. ALC, amplitude leveling, in RF synthesizer is a control loop. There are tons of them. A voltage regulator is a control loop. We could do that more, yes. Yes, I know leakage. Do you think wireless communication will replace wire or even power? Well, wireless communication has already replaced tons of wire, but they're always going to coexist to some extent because of the nature of how they are deployed. Wireless power in near field is very common. I mean, that's how I charge my cell phone. Wireless power in far field and in long distances for very specific applications can be useful. But wireless power is extremely difficult to achieve and it's very inefficient. There's no magic, right? Laws of physics, you cannot get away from them. So people doing beam forming, focusing a beam and so on, they're always going to be subject to people walking in front of it, how often is actually there, how do you switch in and out. There are some really amazing, clever techniques that people have used that I have seen working of wireless power in our labs that they've shown us. But whether it's going to catch on or not, there's so many other things involved aside from a good technology. And the efficiency is always an issue. But in some really specific niche places, it may work. Not all the fake ones, of course, the real ones that actually work. Thank you. Hello, Brazil. Do you think wireless communication will replace? I answered that. Could you speak about current millimeter wave radar challenges? What are the major challenges in DSP? So millimeter wave radar, obviously, is the number one application for that is cars. And more so with cars, because for self-driving cars, of course. And there's several challenges with radar for cars. Aside from making them cheap enough and high performance enough so they can see further, you can have more of them and communicate and so on. Once everybody has them, then interference becomes a bigger issue. And also, the more radar you have around your car, the more you need to compute and co-analyze all the data that comes from it. And ambiguity of multiple radars can be resolved when you have many of them. That's why people are looking at more fancy modulation techniques for radars. They're no longer thinking about just chirps and pulses and FMCW. They're actually doing coded millimeter wave radar transmissions and then doing correlations on the return signal with some fancy DSP. The challenge is always computation power versus cost and so on and on. So there's a lot of really cool stuff in radar. Is there any bibliography, sources, software that you recommend for RF? Yeah, I mean, if you're at university, talk to the people at university. Those are the best people to tell you what is good. And universities often have tons of free access to software. You should take advantage of that. These big companies like Keysight and Cadence, they give these softwares for free to universities so that the students who are graduating from universities become experts in those softwares so that when they go and work in a company, that's the software they're going to buy. That's why they do it. So you should take advantage of that. Big fan of a millimeter PS watching yours. Thank you, and thank you. What are you thinking about USB Type-C? Oh, it's good. USB Type-C is great. I mean, as with anything, there's a bit of confusion right now, a lot of cheap stuff, cheap cables, but once it settles down, there's nothing wrong with it. One of my heroes is... Yes, Mariam is Persian, yes. Where can we watch your interview with Tektronix? I think it's on the Tektronix website. If you just type Signal Path Tektronix, you'll see it. Have you ever smoked weed? Where Have I ever smoked weed? No. I'm going to say no. Those who fix which spectrum analyzer you consider to be better manufacturing? It's a hard question to answer. Obviously, the really good brands like Tech and Roden Schwartz and Keysight, they're all amazing instruments. Amazing. Planning to do a video about GPS? Yeah, I think I did do a little bit about GPS as well. I have another GPS module I still have to do. Green Brazil, would love to see if, yes, and a lot of people are talking about SDR, so I definitely have to do that. Oh no, I lost it again. There are tons of videos on YouTube about dangers of 5G. No. Again, as I said, it's a simple test. You go on the internet, you calculate the free space path loss, and you see that the fact that it even works is a miracle of science. So no, if you go next to an antenna and put your face against it, yes, of course it's dangerous because the power is high. It'd be like sticking your head in a microwave, right? But that doesn't mean microwave, any RF transmission inherently is dangerous. Every study has shown that it's not a problem. And nowadays, even less than before. People were saying, oh, people hold their phone against their head and so on and on. Okay, it's right next to your brain. People were getting worried. I don't know if there's any study that even shows that it's an issue. But now people don't even hold their phone against their head anyway, because everybody is doing non-real-time communication. So even less important than it was before. What is 5G in 1 minute? Okay, so 5G describes how the 4G LTE network is going to change to give you a couple of capabilities that the current network doesn't have. It's supposed to have real-time low latency capabilities so that you can do real-time control systems over the network. It gives you high data rates, and it's supposed to potentially have directed beam as millimeter wave, so high band, low band with massive MIMO at low band at the same time. It's an evolution with one difference that is fundamentally different from how people were thinking about LTE, is that if millimeter wave directed beam becomes a fundamental part of 5G, it's the first time since Marconi where we will do massive commercial communication between individuals using a directed beam as opposed to a broadcast communication. That's what makes it so special and interesting, for me at least. But there is tons that every layer of the network is going to be different at some level. I also remember talking to you on the last day of my internship at Nokia Bell Labs in Antwerp. Oh, that's great. I loved visiting Antwerp. Bell Labs in Antwerp is a beautiful building. I mean, Belgium is a beautiful place. Have you any filters in front of any instruments? Filters, you mean on the power line or on the input? Depends. On the power line, I don't really have anything, but sometimes in front of the instruments, if I have a signal that's really strong out of band, yeah, I can filter it, sure. Yes, isn't it amazing how I can go and buy a DisplayPort or USB-C capable of bandwidth of perhaps a gigahertz in like $10? Yes, as always. The reason is economy, because there is so many. If you wanted to build one chip that does that, it would cost you a fortune. But of course, because you make so many. Siglins and spectrum analyzer have a VNA software feature. Yes, it can only do S11 and S12. Or S21 rather. The reason is because it only has one port. So it's only one transmit, one receive port. Can you explore the values defining RF amplifier, like what gives you the most maximum power it can produce? So RF power amplifier design, you can go write 10 books about it and people have. It's very difficult to get the highest efficiency from the amplifier. And some of the design challenges changes as you change in frequency. It's a whole other topic. And yes, full bridge rectifier. It'd be pretty crazy if actually Mehdi would show up on this, but I don't think this is not that interesting to him. USB-C does not have a 10 gigahertz bandwidth. No, it doesn't have a 10 gigahertz bandwidth. Absolutely. If you had a 10 gigahertz bandwidth, you could put a ton of data through 10 gigahertz of bandwidth. I mean, I use Cadence for simulation and ADS for simulation. Mostly Cadence. I find hardware engineering so hard to get into. The reason you find hardware engineering so hard to get into is because it has a higher cost of initial engagement. Software, in a way, because of that, is easier because you need a PC rather than some compiler. Whereas for hardware, you need so much more. So I get that. I get that it's more difficult. But I also find software more enjoyable. I do have a computer engineering degree, actually. My undergrad is in computer engineering. It's only my PhD that's in electronics. So I have background in both. I do enjoy both, but my expertise is in electronics. Yes, cadence I use. Oh, I lost it again. Have you been amplified 1.1 terahertz if memory is correct? Yes, people have built an amplifier at 1.1 terahertz. It has almost no gain. They built it using devices that had an FT and Fmax of a terahertz in 3.5 indium phosphide. It's an extraordinary accomplishment, but I think it was 10 stages and had a few dB of gain. I forget. It's incredible. It's incredible to think you can pass 1.1 terahertz signal through metallized surfaces on an integrated circuit and amplify it. That's incredible. Any field is open enough that people can transfer from adjacent field? Yeah, of course. Yeah, I do photonics, and yeah, I can go and start doing silicon photonic design if I want to. There's a lot of overlap. We build circuits for silicon photonics, for example. We build circuits for wireless communication. We build circuits for many different applications, and you can jump to the nearby application. It's the easiest, obviously. The field that is adjacent to the field you're working on is the easiest one to learn. And in Bell Labs, it's always encouraged to learn as much as possible from all the fields around you. Yes, wheat does affect memory. Yes, not no wonder it took so long to remember. Yeah, that's a fair point. Memristor, yeah, I mean, the machine learning accelerators using memristors, interesting. I haven't looked too much into it, but computational components with interesting behavior, whatever they might be, can be used for machine learning, of course, and memristors, because of their unusual characteristic, can have benefits in machine learning. I don't know details about it, but it's an interesting thing to learn about. Why is RF electronics like black magic? The reason RF electronics like black magic is because it's non-intuitive, and that's why it's hard, because it takes time to build intuition. Our brains did not evolve in an environment where it was critical to intuitively comprehend how EM fields behave, because it wasn't important for your survival. The same way quantum computing, quantum physics is completely non-intuitive, because your brain just simply is not evolved to deal with it. That makes sense, and that's why you need to build an intuition for it, and that's how you become an expert. How do you measure an impedance of the coaxial cable on a VNA? You can measure the impedance, the absolute characteristic impedance of a cable. You can measure by connecting it to a known load and measuring the S parameter, knowing the length and so on. You can compute that. There are even softwares written to do that. RF is just sound. Sure, from the point of wave, yes, it's true. I mean, waves behave the same way regardless of whether they are in a physical medium related like sound or electromagnetic spectrum. They are in many ways very similar. Ultrasound theory, for example, when I was learning ultrasound theory, I took a course about that in university when I was doing my PhD, because I thought it was interesting, and all the equations are basically Maxwell's equations. Let's see. Oh, I'm catching up to the end of the chat. You guys are getting tired. Is 5G or 4G better in remote areas? Well, I guess in any environment where you don't have a lot of people, any wireless network is easier to build. But I don't think that it really matters in any other way, unless I'm missing something. I haven't tried the software QUS. I don't know what that is, unfortunately. Once you did MA, you said you like to play video games. I love playing video games. I just don't play video games online for a couple of reasons. Video games for me is like a form of entertainment, obviously, just like everyone else. So I like to play video games that have a storyline and play with the story. And I play with my brother over the PlayStation Network. It's like our bonding moments that we've been doing since, for 30 years now, basically. So I play with him every week over PlayStation Network. We take turns playing over PlayStation Lite. We are playing the new Resident Evil, which is pretty fun to play. Before that, we played Detroit, Becoming Human, which I absolutely loved. I've played so many video games. I just love video games with a good, rich story. Fortnite and Apex and all that stuff, no, I don't really play those. There's no point playing online. I mean, there's so many kids which are so good at it that there's no point. I mean, I would have to put 100 hours just to be able to compete, and I don't find that interesting. Yeah, I can try and describe the abbreviations often. Sure, I can try to do that in videos more often. I know it's hard for me because I'm so used to saying it. Yeah, that's right. It was 0.9 dB per stage gain for a 9 dB of gain in a 10-stage amplifier that had a 1 terahertz bandwidth. That's right. That's what it was. What's your opinion on cryptocurrency? Oh. So I'm not a sufficient expert to give a strong opinion. Blockchain technology itself is really incredible, obviously. It has a lot of applications. I don't know about cryptocurrency. I don't have any cryptocurrency. I haven't really dwelled in it too much. I know some people really, really like it. Some people have lost a lot of money. Some people have a lot of virtual money. I'm a little bit concerned about how much energy is put into it. Honestly, don't know enough about it. It's one of those things that I should. It's just there's so many things to learn. Not enough time, honestly. But if somebody can point me to a cool place, sure. What do you think about communication like DJI Sync? I do have a DJI drone. I don't have the latest one, so I don't know what Sync is. But some of these custom communication protocols are about optimizing the protocol for two reasons. Why? To make it proprietary, so only they can use it. And second, to embed information in it and get more out of the network and out of the bands that they're using to bring real-time You don't want to use, let's say, Wi-Fi in its inherent Wi-Fi to do something because it might be too slow. So then you use the same band because you're allowed to, but then you make your own protocol, which is much more real-time. But then you have custom hardware. That's probably something like that. I haven't really used it. I mean, like wireless mice, for example, right? Wireless mice are 2.4 gigahertz. They have their own little protocol. They're not like Bluetooth in a traditional sense. Have you tried digital modulation? Do you understand clock feed through crosstalk? Yeah, I think I understand those things. Well, digital modulation in what? You can do digital modulation in anything. Clock feed through is an inherent problem in many systems and many circuits. And in a wireless system, if you have, let's say, a clock of a DAC that's leaking to your transmitter, then you're sending a tone, which is the clock of your DAC, out of your transmitter over the air, which nobody cares about. So you want to filter it out. So it's really tough sometimes to get rid of these spurious tones that you're not interested in out of your band. That's why people use filters in wireless because they can meet the requirements of the mask, because you don't want to pollute the signal everywhere for other people who need to use the spectrum as well. But yeah, there's tons of resources that you can learn about. How people deal with these things is often by filtering. Calibration can get rid of things. Perfectly symmetric circuits do not have that kind of feed through often, and people use calibration to get rid of that. When will you review the Signal Hound? Yes, the SM200A is an incredible instrument. I'm really excited about that. They're making some changes to it. I can't talk about it. Once they're done, I'll review it. I'm really looking forward to it. It's an amazing instrument. It's so much fun to see what it can do. That's a really cool software-defined radio. Ever consider robotics? Yeah, robotics is cool. I mean, like I said, I do integrated circuits. So if I built in circuits for robotics, sure. How's my cat? The cat is great. Pooj. Come here, Poochy. No, he's sleeping. He's not gonna come. He only comes when he wants to. He did wake up though. Come here, Poochy. Come on, Pooj. Well, no, that's the extent of my cat's when he's sleeping. He's normally very good. He normally comes when you call him. Nikola Tesla is an amazing engineer. His ideas seem well ahead of the time. How can analog RF circuit seek to do similar things? Well, so the issue is that things have gotten so much more complicated. So explosions in completely changing a particular field's understanding are not going to happen as much. Now they're happening more and more in different places. Obviously, we've made leaps and bounds of how we understand quantum mechanics, leaps and bounds of how we understand genetics. And there's only so much you can do in every field before the field saturates and something new comes out. So it was a little bit different when a field like electronics was revolutionized. The way that field changed obviously was extraordinary. Now it's optimized and settled, and things are getting fine-tuned, and different specialties are emerging, but there is so much to do. Manchester Decoding. Yes, what music do you listen to? I tend to listen to instrumental simply because if I listen to music that has lyrics in it when I'm working, my mind immediately locks to the lyrics. But I like a lot of different indie bands. I like the old bands. I like the Eagles a lot. I like Metallica a lot. I like a lot of different music. Probably a kind of music I don't really listen to. Don't listen too much to country. Haven't listened too much to rap. But I listen to anything that's good. How do you handle large variation in load impedance designing PS? Yeah, that's a really tough one. Large impedance variations in PA design, especially when they're connected to antennas and so on, can cause a ton of problem. And people are really good at that. There are some PA architectures which are inherently really good at being insensitive to load variation. So people use those, obviously, like balanced PAs and so on. I plan to launch a YouTube channel about repairs. I don't know a thing, but I don't know a thing about finding. Well, like I said, I use eBay. Sometimes garbage, if you can find some, but repair anything. I find that people will watch repairing anything. It doesn't have to be anything specific. Your brain rewards you when you watch someone else repair something. And if you love the thing they're repairing, even more so. That's why I love watching repair videos myself too. What is your view on integrating full millimeter wave TX-RX on CMOS? People do that all the time. Versus multiple chip package with digital baseband in CMOS and the millimeter wave. Yeah, people also do that where they split the CMOS and the silicon germanium or gas into separate chips because they want to get the best of both worlds, but then the cost of integration, everything goes up. But more and more people do integrate things on CMOS with limitations, obviously, right? It all depends on the application. But both are valid. More and more in CMOS though, because of the SoC capability. When you said your cat would come when you called, I doubted that. Believe me, he does. Pooj, there you are. Come here, Poochie. Now you listen. See if people were insulting you. Come on, Pooj. There is Pooj. He's a good cat. He also likes when you do this to him. Oh, that's the stuff. Yeah, he likes that for whatever reason. He's a weird cat. Okay, hold on. Now I can't see the screen anymore, cat. Explain injection locking. So, if you have an oscillator that's free running, the edge, imagine that the tone is generating. The edge of the tone can move back and forth because doesn't have a reference. It's free running. The temperature effects and the noise from the circuits, they drift back and forth. If I inject the frequency at the harmonic of that signal into the oscillator core, the edges of the oscillation are going to line up with the edges of the injection lock because that's the condition of the lowest amount of energy transfer. And then they lock together. So every time the signal passes through, you lock to the injection lock signal. So you can inject something in at a different frequency and lock at the multiple harmonics of that frequency. You see, that's what happens when you call the cat. Now it doesn't go away. Who is the thumbs down? I don't know what that means. What is scientist through history do you admire the most? Ooh, there's so many. I obviously love Carl Sagan. Love Richard Feynman. There's so many. Madame Curie, she was incredible. She was, imagine, at a time where women had almost no influence in science. She's the only human being with 2 Nobel Prizes in 2 different fields of science, and one of the only 4 with 2 Nobel Prizes in any field of science. I mean, this is an extraordinary thing. A committed, dedicated, devoted, true scientist. There are so many of these people when you go and see and listen to what they had to say and how they thought about the world. Only if more and more people thought about the world in the same way, what a different world it would be. Besides modulation detection, that does statistics play a role in physical layer modem wireless communication? Besides from yeah, I mean, it's the statistics in general plays a role in a lot of analysis of error correction, coding detection, all these probability, communication theory. They're very, very important. I'm really interested in computer engineering. I'm not sure whether to go into research or industry. That's a really tough question to answer, honestly. You can go, I find that sometimes if you're in research, it's easier to go into industry. But if you're in industry, it's a little harder to go into research because of the requirements that people have in research when they want to accept someone new. It's not always the case. Go somewhere. Oh, this is the other thing I wanted to say. Even people always say, oh, make sure you do what you love. Yes, of course. No, not everyone's going to have that chance. I realize that. But doing what you love is important. But even doing what you love with people who you don't enjoy working with is going to become a chore. A lot of times the people you work with are just as important as what you do, so that you can be joyous when you go to work and enjoy communicating with people. It's very, very important. I think your cat is broken. Do you consider yourself as a scientist and engineer? I would say I'm both, but certainly a scientist. Can you electroplate the 3D printer millimeter components? Yeah, I thought about that. There are ways to electroplate plastic. It takes multiple stages. You have to first put something that accepts the metal, adheres to the plastic, and then do electroplating. Don't have the equipment to do it. That's why I just used the spray. It was amazing that it worked as well as it did. Okay, a lot of this 2048 BK. I don't know what this is, and it's come up now several times. So let me see what Google says about that. Let's see what this is. Oh, it looks nice. DC resistance meter featuring high accuracy in a milliohm range. Oh, interesting. It's a fairly specific instrument, just for measuring ultra low resistance. Yeah, efficient low power resistance testing. I've never had one. I'd love to get my hands on one of these. 0.1 microohm to 100 megaohm. That's a massive dynamic range. RRR TLPR. It's not that expensive. $1,500? Huh. I don't know. Maybe BK Precision. BK Precision, are you on the chat? If you are, say yes. Send me a DC resistance meter model 2841 and I will review it. Do you like Louis Rossmann repair videos? That's the guy who prepares the Apple parts, right? So I watched a little bit of his videos. It's great that he's sharing his knowledge. I didn't particularly enjoy listening to him so much. He goes on and on a lot about other stuff, which some people like to listen to. I care about people sharing their knowledge, which is exactly what he's doing. So whether I like, particularly listening to him or not is not really relevant. But I'm glad he's doing what he's doing. I don't really honestly watch his videos so much because they're so long, and I like watching videos that have high concentrated amount of information in it just because of time, and no other reason. So, and I sometimes have to watch videos in higher speed. I've obviously watched everything Dave has produced, and Mr. Carlson, and Electro Boom, and Alan from Tech, and a few others, the big names, obviously. There's so many incredibly talented people. We are grateful to have these people share that information. Really, we really are. Yes, Madame Curie's notebooks are still radioactive, yes. Yes, Miss, yep, I know you're missing your cat. That's one of the things that I'm always really worried about. Yes, Pooj is now 9 years old or so, almost be 10. There'll be a day he won't be around. That's pretty tough to think about, I have to say. you know, he's just a cat at the end of the day, but it's not just a cat to me. And he's been with me since he was born, and there's a connection, and that's really, really hard. And when you get a pet, you're committing yourself to go through the tragedy of potentially losing them, because that's the most likely probability that you will lose them, and it's really tough. But that's what it is. It's a famous saying that friendship of any kind must take risks and accept that that's going to happen. Yeah, 5G on the cell phone is certainly, people are working on it. It's a tough thing to do though. That's certainly because of the way you hold the phone, and your hand can block the beam. You have to have switched antennas. A lot of people are working on that. What kind of return loss measurements are you seeing in your 3? I haven't done return loss measurements at millimeter wave frequencies because I don't have the equipment for it. The highest frequency I can do return loss measurement on is 13.1 gigahertz in vector. I can do return loss in magnitude up to 40 gigahertz. But if you want vector, that's a network analyzer. That's the only one I can do. And I actually repaired that instrument on camera. That's how I got that capability. It's one of my repair videos, the Agilent 13.1 gigahertz VNA. Is it educational to learn about the particular communication standard? Depends on what you're doing. So if you're designing something for a particular communication standard, then obviously you want to know that communication standard. But the standard itself is not that critical if you're talking about circuits, only to some extent. Some standards are going to require a type of waveform that puts a particular demand on the power amplifier, just as an example. Then obviously knowing about it helps. But the details, just the little nitty-gritty details of the standard, if you're in the standardization, obviously. If you're building hardware, not sure how much that matters, unless you're working on the modem, in which case matters a lot. What's the cat's omni-tail antenna gain? I don't know, but I would imagine it's pretty poor. When Pooj was little, we closed the door on his tail by mistake, so the end of his tail broke into a 90-degree bend, and he still has kind of a bend in it. I felt so bad, poor guy. Thought process on repairing. Well, you see my thought process. I try to put the thought process on camera every time I get a chance, and it's systematic, as with anything, any kind of scientific process, a very systematic approach. What's the story of Pooj? I got him from a shelter when he was just born. He was one of 3. He had a sister and a brother, and the sister and the brother had extra toes, which is a genetic defect that apparently happens with cats. So, but Pooj was the friendliest of the 3 when we were playing with him. So we took Pooj, and it was funny because when I played with all 3 of them, they put them back into the little cage, and this little kid came in, and as soon as he came in, he pointed, he's like, I want that one, which was Pooj. I was just about to throw the kid away because of the fact that I didn't want him to take the cat. But of course, I'm just joking. The kid was very little, so he changed his mind very quickly, and he just went with a different kid. The Lewis Rodman IC reball info is badass. Oh yeah, he does. He has the. So that's actually the videos I've seen. So he reballs the ICs by a fixture that aligns with the balls on the back of a BGA package, and you can fill them with these little tiny solder balls you can buy at a particular diameter, reflow it, and then you remove that, and then you got a reballed IC, and you can reflow that back again on top of your PCB. It's amazing that he does that. First of all, you need to have the technique and years of practice, but you won't even know if you succeeded until the very end. You have to do so much work before you know if it even worked. So I admire that. That's a lot of patience. How do you manage your time? I don't. I am really bad at that. I have to say it's a continuous improvement. I find that when I get more efficient, so you would think that when you get more efficient, you get more done. But when I get more efficient, I get worse at time management, so I have a steady state. I always try to get better. It's for sure, it's a skill. It's really important. What is your opinion? Does Kirchhoff's law hold? Yeah, of course it holds. Here's what I thought about that. I think that whole Kirchhoff's measurement thing has been settled, but here's the issue. if your measurement on a circuit, on a system, is subject to how you're measuring it, and if I move your wires around, your measurement changes, then you cannot draw any conclusion until the measurement itself is fixed. So it doesn't matter what it is you're investigating. Okay, you cannot use the result of that measurement to justify the thing you're trying to explain if the measurement is wrong. Even if your conclusion ends up being correct, the path to that node is incorrect. So if the measurement is wrong, forget it. And as soon as I saw the measurement was variable and it had to do, then the rest doesn't matter. And if the system is not modeled, then of course you're not going to be able to analyze it. Who was the inventor of the transistor? Well, it's always a question, but officially Shockey for sure. If you can use one instrument. If you can use one instrument that you don't have, what will it be? Well, it's going to be the BK Precision DC resistance meter, model 2841. No, I'm joking. Instrument that I don't have. Well, instruments are in classes, right? So I have classes and categories of instruments. I have every category of instrument within my field, but there's a lot of really cool physical testing, physics experiment like spectroscopy and other kind of instruments that I don't have, which would be cool. Some new instruments on just fancy new modulation analyzers and stuff that I don't have. I recently got something. I'm going to review this. This is the new Tektronix arbitrary waveform generator. It's a very nice instrument. It's going to have to be opened up and reviewed at some point. Are you Italian? No, I'm not, but I think you're saying that because I move my hands so much. What about simulation versus paper mathematical? A lot of work on paper is useful to get the initial idea, but you can't compete with the computational power of a computer at the end of the day. So, but if you don't know how to model what you're working on paper at least a little bit, then you can't really rely on the simulation anyway, because to me, that means there's a bit of a lack of understanding of what it is that you're working on. And it's always a challenge because a lot of advanced simulators can make people, including myself, lazy, because you can do so much to get the answer that you can try many avenues without fully grasping why you're trying all those avenues. So I'm a huge fan of understanding things with, of course, limitations of time. The Roden Shores network analyzers are pricey, but they're very, very good. And you're welcome. Interesting, the best scopes tend to cost more than the best VNAs. Only some scopes. I think on average VNAs can actually be more expensive, but yeah, you're right. I mean, if you're going to buy a $1.3 million oscilloscope, that's really hard to compete with in terms of network analyzers, but there's only one or two of those. Do you have some experience, interest in optical? Yes, OSAs must be beastly inside. Yes, they are. Yes, I do have optical. I have done some optical repairs here on the lab. We work with silicon photonics. Obviously, it's not my core expertise, but I know about it. Do you have any hobby besides electronics? Yeah, I like playing sports, going to the gym, seeing family and friends, and so on and on. All the usual things. I like photography. I haven't done that in a long time now. I haven't had a chance, but obviously playing around here in the lab and stuff. That's always been my passion. Will I be at IMS this year? Yes, I will be at IMS. It's in Boston in June, and they have an incredible industry trade show. And I will make another episode about that like I did last year. If you want to increase subscribers, what about EMC video? Basic EMI testing. I mean, EMC testing and EMI testing, these are still very specific, right? That's not going to get you 100,000 subscribers. But if actually everybody who watched my videos was a subscriber, I'd be over 100,000. I just want that stupid plaque. I know it's really shallow, but I do. RFIC versus IMS versus ISSCC. I'm on the technical program committee of RFIC. IMS, I am not. I do have a couple of talks at IMS, some workshops at IMS this year. ISSCC is obviously a huge conference. I was there this year. Under-screen cam with ultrasound? I'm not sure. Can you make an under-screen cam with ultrasound? I don't know what that means. College education, where did you go? I have all of my degrees from University of Toronto in Canada. And I paid, back then, I think $4,000 a year for my undergrad, and then everything else is free. Yeah, Dave, as I said earlier, Dave is amazing. Really, really, really nice guy. Very nice guy. Dave Jones. He's the reason why I started. Actually, one of the reasons why I started. I said this story before. I went on his forum when his channel was just very young and he was competing with others, and I asked if I should start a channel, and he encouraged me to start. Basically, he encouraged me to compete with him and potentially. I mean, he didn't know at the time how big he was going to get. Potentially compete with him in a serious way. That is character that I really appreciate. Yeah, no. Do I have an Italian accent? How is that? I don't know. I didn't know that, but I guess that's kind of cool. I'm not an amateur radio operator. No, that's one of the things I wish I had done. Are you good at math? Well, I took tons of math courses. I've forgotten so much of it. But when I need something, I have to go learn it. But math is one of those things, just like a language. If you don't use it, you tend to forget it. Math is the language of the universe. It's the most important thing. How important transmission line effects at 50 megahertz? Transmission line effects at 50 megahertz for short lines, it doesn't really matter. I think crosstalk and high frequency contents on digital lines, on that is going to be more important. If you want subs, I'd go heavy into lasers. I actually have a non-solid state laser. It's not here, but I was going to do a repair on that. It's hard to do one video and hit 100,000 subscribers. It's not going to happen. My topics are just too specific. The conductive, the spray they used, probably all you need is a base layer. Yeah, I agree. I just haven't tried it. Samsung uses under-display fingerprint sensor. How can you make an under-screen camera with ultrasound? Well, ultrasound conducts through whatever medium is sound, so it's a little different. In fact, that little gel they put on the body when they use the ultrasound head, that's just an impedance matching layer. It's to avoid reflections when the sound comes out of the ultrasound transducer, hits air and hits your body. They're putting something to mimic a continuous impedance, optical impedance. Oh my god, no, my brain is now stopping. Acoustic impedance between the transducer and the body. That's what that gel is. So you could put ultrasound in anything. The question is how you receive it and how good it is. There's a lot of other challenges. What is your opinion about neuromorphic electronics? No, I haven't looked into it too much. University of Toronto versus University of Waterloo. Ooh, I know Waterloo has had historically an incredible software computer engineering department, and still does, I'm sure. When I was applying to university, it was at the peak of when people wanted to go into electronics and computer engineering. It was at the peak before the bubble. So when my high school average of my grades was 94%, and I barely got into university with 94%. I mean, barely. I didn't even get into a computer engineering program at Waterloo because my grades were not good enough with an average of 94%. I got into chemical engineering at Waterloo, and I didn't want to do chemical engineering, even though I've always really liked chemistry. So that's why I went to University of Toronto. But now it's totally different, time changes and so on. If I recall correctly, there was a video that experiment measured the switching time of an LED. It would be interesting comparing different LEDs. Goal of optical communication. So free space optical communication for like LEDs and so on is interesting. I just haven't seen any products really use it because you're competing with Wi-Fi. So why would you try? And if you're saying, well, there's a lot more data rate, and Wi-Fi can also give a lot of data rate. Yes, you can put it in light bulbs and so on, but then, your shadows and things get in the way. It's hard to do. Measuring the frequency response of an LED, we can certainly do that. It should be an interesting experiment. Regular LEDs are not going to be very fast. If I recall correctly, there was a video that experiment that measured, I read that already. Get your ham license. Yep. What is your take on custom accelerator for AI application? Yes, custom accelerators for AI application is a very active and interesting field in ASIC design because a lot of the neural network and machine learning algorithms are heuristic and they don't need as much resolution and precision. What they need is density and interconnectivity. So you get away with many less bits, which is the opposite of what people do for general microprocessor design. So you can make very efficient systems as a result of that, and people are looking at that. What is your approach to solve difficult problems? Break them into simple problems. Talk with people who are experts. Go look at the theory, look at the best work that's done on the market, and so on and on. I second beamforming video request. Yeah, I just bought where is it? Hold on, let me grab it. I just bought one of these. Yeah. There's a 60 gigahertz beamforming phased array in this from Cybeam. So we're going to take that apart and take a look at it at some point. Yeah, a video on different PCB materials. So one of the cool things we could do with the PCB machine that I have is to basically make the same layout on 3 different materials and then look at the loss. Obviously you have to adjust whatever you're making. Let's say I make just a transmission line just to measure the loss. Very simple. We can make it, have to take a different width because impedance is going to be different because the electric constant is going to be different, but then we can compare them with the unit of loss, let's say per millimeter. Then you will see the electric loss tangent directly in play there. What kind of collaborations with other channels do you like? I'd like to do collaborations. It'd be cool to do a collaboration with, well, I've done collaborations with, obviously, with Dave. I've visited them and we've done work like that together. It'd be cool to do with Applied Science. I'd love to visit him in California, do something with him. With Mehdi in Vancouver would be very cool as well to do. With Mehdi would be cool because he just doing that will surely get me to 100,000 subscribers. What is the future of electronic engineering? The future of any person is different than the future of a field. A dynamic personality that can learn and adapt is by far the most valuable. So if you do some, I did computer engineering and then went to electronics, I may do something in the future. In fact, the president of Bell Labs, Marcus Weldon, he's a chemist. The head of AI and machine learning, also a chemist, has a chemistry PhD. So they switch fields and they learn something completely new. And those are intelligent people. With Cody's lab, yeah, that would also be great. But I actually don't know where Cody lives. I have never spoken to him. Obviously seems like a really nice guy, cool experiments, loves that stuff. It's kind of a nitty-gritty approach to doing some science, which is very cool. I'm more love like things have to be very proper and so on. It's different personalities, but I love his channel. All right, are we reaching the end? Oh, the X-ray machine is sitting on the other side of the lab. It's going to be hard to show you, but I'm going to use it more and more in videos, for sure. Oh, the other thing I forgot. I had promised to do a giveaway. I will. So I will take, since I recorded this, I will take everybody who was on the live show today, and I will pick one person randomly, and I will give away something. Let me grab it. I should have prepared this in advance. All right, here it is. I'm going to give away one of these oscilloscopes to one of the people who were on the live stream. Since you guys spent all this time with me, Oh god, I have to open this again. Okay, fine, I'll open it. Ugh. Here it is. One of these nice oscilloscopes. This is the 100 megahertz, 2 gigasample per second DSO 1000 series. I will go over the video and see all the names. I'll figure out a way to take all the people who were contributing, and I'll just pick one randomly and I'll send it to you guys. So the other one that I have given away already was to somebody who was in Australia, and I mailed it and he never got it, and then all of a sudden a long time later it came back. For some reason it went all the way to Australia and all the way back because it was undeliverable, which is crazy. Just think about that. Thing's already been around the world. I have to send it back again. So anyway, I'll send them at the same time. And there will be more giveaways for sure in the future. Alright, so any other questions? I think we're right at the edge of 2 hours. I really appreciate it that you guys stayed here with me, and it was really fun to do this. I don't know how many of you guys were there, but it was awesome. Thank you so much. Now, any other last minute questions? Is the giveaway sponsored? No, that is my scope that I'm giving away. And you find an FR4 photoresist. Any other questions? You're all welcome. Yes, so what I'll do is that, like I said, I'll go through everybody who was there at the live stream. I will pick one randomly, and I'll contact you guys through YouTube, and I will send it to you. How many instruments do you have? I love sushi. What's your favorite food? Sushi, Indian food, Italian, French, you name it. Good food, any food. I have a long list of things to repair. At least there's 10 things in queue. And I hope you enjoyed this. I will see you guys next. I think I have recorded this, so I should be able to just process it if it requires anything, and send you guys one of these scopes and put it on the YouTube channel. Okay? Thank you all, and I will see you in the comment section. Let's see if we can get the channel to 100,000 subscribers. I'll see you soon.